Jain students, I Ayushi Gupta welcome you once again to the lecture series of programming for problem solving, and today's topic is searching and sorting algorithms. So first we will be looking at the searching concept in programming for problem solving. So students, in your syllabus there are certain searching and sorting algorithms that you need to study. These algorithms are very important because you have studied one data structure, that is array, and for performing one of the two of the basic operations of searching and sorting on that data structure, we need certain procedure. So there is a standard that is adopted, and their program is also made to implement these functionalities, so that you can have operations performed on the data structure, that is array, in your scope. So there are certain standard algorithms that needs to be followed and understand, very important as a computer science and engineering student. So for searching, we are having linear and binary search, and sorting algorithms we will be studying and in the form of bubble sort, selection, and insertion sort. So in today's lecture, we will be focusing on the searching algorithms. So let us understand the concept of searching with respect to data structure and algorithms, and how to implement these algorithms. So the first operation is searching. So student very well know, as the name suggests, searching is to search a particular element in that data structure. Under searching algorithms, we need to find out if any particular element is there in the data structure or not. If it is there, we should return the position of that element in the array to the user. And if it is not present in the array, then also it should give a message to the user that the element cannot be found. So this searching algorithm can be classified into two categories you will be learning in the form of linear and binary search. There are linear and binary search, both are used to do searching in an array. So let us have a first look at the concept of linear search. What does linear search? What is the procedure of linear search that we need to understand? Okay. So for understanding this, let me consider one example. So to understand the concept of linear search, students, I have taken one random array. Okay, let us consider an array having elements as 19, 1, 2, 3 and 4. Okay, so now our requirement is to search whether the element 2 is present in this array or not. So for this student, according to the linear search, the very first step is of this algorithm is that you first access the element present as at the very first index, that is accessed by the zeroth index, that is referred as zero index. So we access, let's say the name of this array as A, and we access the element present at zero index of this array. So zeroth index element is 19. The next step is the element that you have accessed, as you must have learned in PPS that you can access the elements of any array with the help of its index value. So I have done that thing only here. So the first index value is 19. We compare it with the element to search. This is according to the linear search procedure. Okay. So the element to search is 2 and we have got 19 from the first index. Now you compare with 19 with 2. Is A 0 is equal to the key element? We refer to the search element to be searched as key element. Okay. So now the element is 19 and the search to be is 2. So if we compare by equality operator, 19 is not equal to 2. So we didn't find our element at this block. So for this, the next step is to update the index position. As you went to the first index, now since the element is not found, you update your index position and proceed to the immediate next element. The immediate next element is 1. As first we went to A0 and now A1, the index is updated. So A1 is having element 1. 1 is also not equal to 2, that we can very well visualize. So 1 is not equal to 2. So our index element, our key element is also not found. So again, update the index position. So that means now we come to this index. We have done this and now we are at the second index. Okay. So A of 2 is 2. If we compare with A of 2 with our key element, that is 2. Okay, so 2 equal to 2 only. So here at second index, the second index of array A, we found our element 2 and 2. The element to be searched was 2. So both are equal. Here the search completes and you found your key element at the second index. Second index, or you can say at the third position of the given array, the element is found. So we have done these steps and in this way we have found our element present in an array or not with the help of the steps given by linear search algorithm. Okay. So let me consider if 2 was not present here. Okay, 2 was not present here. So you will keep on updating the index positions and accessing the elements, and we keep on comparing it with your key element. Okay. If the moment comes that the index array position goes out of bound, like if in that example we were not having 2 anywhere, so we went out of bound in this array, so our search procedure also stops there. Okay, but if it was at last position, that way it will be proceeded and at some time it would have come to the last position. Okay, so this way the linear search procedure works. So it is linear search because of the name, as because we can very well see that it is proceeding in linear search, linear manner. Any array you are having, the element you need to search, you are proceeding in a linear manner, visiting each block one by one and keep on updating the index positions. Okay, so you can say that it is linear search algorithm because it is linear in its working nature. So these are the algorithm steps. For any algorithm you would be writing the steps also as you have done in first unit. So for algorithms, so any algorithm from exam point of view also write the steps of the algorithms. Okay, so these steps say, as we have done this in this previous example, that first we set the index to 1 or you can say 0, then you check the range in which you have to visit the array from its starting index to the number of elements, and now we set to the we keep on accessing the elements from with the help of index in step 3 and compare it with the key element that we need to search. Then if it is not found at that position, we update the index position and the same steps repeat. So this is the implementation of linear search algorithm. Very easy to understand if you have understood the example. Okay, so for this program of linear search, we have first created the array from user. Okay, in this example, we have taken the number of elements and the elements that should be present in array from user. With the help of printf and scanf statements that you know that you take the input and output in the form of these in the C programming language. So first you have printed the message how many elements, then the user has given choice, then the array elements have been entered by the user. For this we have used the loop. So this you have already done in array. So certain array we have required, I have declared one integer array which I have taken. Your choice, you can take any array, any name you can take here, any size you can take here, that should be sufficient for your array elements. Then I will be needing some elements like variables like I for indexing, X for the element to search, and N for the number of elements. Okay, so after these variable declaration and this basic input output, we come to the linear search procedure. So once the array is created, we have taken the choice from user that which element to search. So the message is printed on the screen, enter element to search. So the user has given requirement and we have taken in the variable X, right? So now once we are done with the which element the user has to search, and the array is already created in the memory. So now we apply the linear search algorithm. So as we have understood the steps of linear search algorithm, we will be implementing it in the form of logic for the program, right? So for this program student, for this logic, try to understand that you will be visiting from starting to last. Okay, in this array for linear searching, you need to visit the first block till the last block your element is not found. Okay, so for that you can use any loop, but the basic and easy loop for this is for loop, right? So for loop you can use for indexing I is equal to 0, you can start from 1 also. By default I have started from 0. So for I is equal to 0 suggests that for index 0 to of course we have to run this loop from less than elements. If you are starting index from 0, then we take I less than n. So now I is equal to 0, so the loop condition forms to be I is equal to 0, I less than n, and keep on updating I plus plus, right? Now within this loop, what we need to do, as we are visiting the for current I0, okay, I0 means that you are at index 0. For that, when you are visiting the element, we need to access the element and compare it with the key element. Okay, so for this logic, when your current index is 0, the element should be fetched and compared. Okay, the compared to be element is in X. I have taken the variable X for that. So what we are doing, we need to check anything you need. You very well know that you have done in the starting units that the comparison operators are formed to be conditioned and return their result in true or false, right? So I have made one condition that if A of I is equal to X. Okay, so since we are doing equality check, so a double equality operator is used. So in between what we are doing, when we are at index position, any index position, then we are fetching that index according to A of I. Okay, so A of 0 will be fetched and we will compare it with the X, right? So if A of I equal to X, right? So let's say in this example, A of 0 is 21 and the X is 87. Okay, so now 21 will be compared with 87. Is it equal to these two are equal? No. So yes, this thing is not equal, right? So if it would have been true, then we will proceed in this block. But since this condition is failed at starting only, you will not proceed further, right? So now it will go back to the loop, for loop, and when you go back to the loop, the third part is fulfilled, that is I plus plus, so that I1, right? So this way you can understand that what we have done earlier in the example, now we are updating the index position that we need to do for further blocks traversing, right? So I plus plus will become 1, and we fetch the index 1 position. So index 1 is 22. 22 will again compared with 87. So this loop, this we have used loop so that the certain steps repeat and keep on checking and accessing the element, right? So again 22 will be compared with 87. These are not also equal. So when it will reach here, as we can see here, this will be done by program, but we can visualize it that when it will reach here 87, so 87 will become to our x value, that is 87, and it will enter this block. So the condition will be true and it will print the message that element found at index this. Okay, so this way you can utilize the index value that would be currently to return your position and message to the user that at which index or position your element is found or present in the array, right? So element found at, it will return the value. So we will not be checking further steps. We will, if any element is found in between array, you need not to proceed further in the array. So in this, for implementing this thing, we use the break statement here. Break statement concept is clear, must be clear to you, that break takes you immediately out of the loop. So as your element would be found, you will not proceed further and break out of the loop. So we have used the break statement here, right? It will not update, it will not update further I plus plus and will not enter into this loop, and we come out of this. And if we go out of range of the array after this implementation, if we go out of the range of the array, it exceeds the value of n or n only, so that we need to print element is not found, right? So for that I have made this condition. So this is a program of linear search. I hope this concept is clear, because what we have, linear search is very basic and easy to understand algorithm for the basic operation of searching. So what we have done in the example of linear manner searching a particular element, that only we have implemented the program in the form of logic. So after linear search algorithm, the second algorithm is binary search. The name is binary search algorithm, and this is also used for searching. Okay, so for searching you are having two basic algorithms, linear and binary search. The target of both is to search a particular element only, but different people have, different researchers have given their approach, and the approved ones we are studying, and these are the standard names. These are the standard names, and their working procedures is quite similar or a little different from each other, but they are doing the same operations only. Okay, so as we have discussed linear search, now we come to binary search. So for binary search, let me first consider one example to understand how binary search works, then we will be looking at the theoretical concepts of it. Okay students, so students, look at the slide that we have taken one array having elements as 4, 2, 9, 7. Okay, so now it is a searching algorithm. We need to search, let's say 9. Okay, I have to search whether the element 9 is present in this array or not. So I will be implementing now the binary search procedure, the steps given by binary search, right? So students, please note carefully that binary search is only applied to sorted array. If you need to implement binary search, the array should be sorted in ascending order only. Fine. So now, if you are having 4, 2, 9, 7, the sorted array would be 2, 4, 7, 9. This is arranged in ascending order. This is the first condition of binary search. Now this is our array, this is our modified array now, and now we will implement the steps on this array, not the previous one. This sorted ascending order array, in this we will search our element is present or not. So after this first step, the second step is to find the middle index of the array. Okay, because it is binary search, it is binary in terms of to divide the array in two halves. Okay, binary is 2, so that is dividing the array into two halves, first half and second half. Okay, for this division, from where to divide, we need to find the middle index value. So the middle index value formula, we will be using the formula low index plus high index upon 2. Low index plus high index upon 2. Low index is the starting 0 index value and high index is the last index of the array. So in this particular example, the middle index value will be low index is 0 and high index is 3. So 3 by 2 is 1.5 and we consider the integer values only. Okay, so with this we get the middle index as 1. The third step is, after you find the middle index, then you find the value at that middle index. Okay, so the value at that middle index, okay, look at this example that now the index 1 is having the element 4. Okay, 4. So you fetch the value present at that middle index, we got 4. Now we compare this 4 with our key element. Our key element is 9. What we need to search? 9 is present or not. So we compare with the element present at the index position with the key element, right? So that's why I have compared 4 with 9. So 4 is obviously not equal to 9, but we need to analyze whether 4 is smaller or greater than the key element, right? So 4 is less than 9. Okay, student, what is the significance of this analysis? Because we have arranged the array in ascending order. Okay, the element you need to search, if it is greater, must be present at some last extreme of the array, right? And if it is some smaller element, you will find out in the first or starting half of the array that you have sorted. So 4 less than 9 means that you have divided the array at the middle index position. So that means that 9 will be found after this middle element. This analysis is required for this further processing, further steps of this binary search algorithm. So yes, you can visualize it as I have divided. We got the middle index as 1. So I divided with red dotted line, I divided this array into two halves, right? So since 4 we got less than 9, so 9 we need to search in the second. Now the array is divided into two halves. So 9, we will be looking for 9 in the second half of the array, and we can ignore the previous half of this array, right? So with this approach, we consider this second half having elements 7 and 9 in this array. So now students, again the steps repeat that now the array you are looking at is itself an array, and now you again apply the steps that you done previously in the starting. So now again you find the mid index, but note carefully that for mid index what you require, if you are in the second half of the array, then low index is changed. Okay, high index remains same because you are in the second array, and high index is last index only, so there is no change in that. But now for your middle element, low index is mid plus 1. Note carefully that now if you are in the second half of the array, you will update the low index as what you got in the previous mid index plus 1 always, right? So in previous step we got mid index as 1, now it will be 1 plus 1 as 2. For us, the second half for mid index finding, the low index is now 2, right? 2 plus high index is 3. High index, there is no change, you are in the second half only. So 2 plus 3 upon 2, that is 2.5, and we will consider only 2. Right? So now our mid index is 2 of this second half array. Now again that step we find the element present at that mid index. That mid index is 2 now. So now look at the array having elements of that we have considered is now having element as 7. at this mid index the element is 7. So 7 again compared with 9, 7 is again less than 9. That means we again come to the second half of the array. We again didn't find our element that we need to search. Okay, we need to search further. For this we have compared with the mid element, and now we have analyzed that since 7 is less than 9, so we will be looking for 9 in the second remaining half of the array. So we again visualize it and divide the array with this mid index that we found to be 2. So since you are again in the upper half of the array, so now again low index is updated as mid plus 1. So in this step we got mid index as 2, right? Sorry, mid index, yes, mid index as 2. So 2 plus 1, that is 3. So 3 is now your low index. So 3 plus high index is 3 only. 3 plus 3 upon 2 is 3. Fine. So the element at this mid 3 is 9. Now we compare it with the key element that was 9 only. So 9 equal to 9. That means we came to the result that element 9 found at the index 3 of this array. Okay. So if in this example 9 was not there, so we update further our index position, and at some moment we cross the boundary of the array and we could give the message that element not found. But since you are proceeding in the halves in this manner, this way you have found your element. So student, in this example the element was 9 and we found at the upper half, right? If it was some smaller element, so for that smaller element you would be considering the first half of the array. When you are in the second half of the array, when you are in the upper half of the array, you update the low index value, and if you analyze that you will find your element in previous half in the at the smaller side of the array, then we update the high index value as mid minus 1, right? That is very obvious. So this is the program for binary search implementation. Very easy to understand, student, this program, if you have carefully done the array programming. Okay, so we have created the array. The variables required I have declared and mentioned as low as 0 and high is n minus 1, and mid I will be calculating by using the formula this, and mid I have taken int only. Okay, so that thing is solved here. I have used the while loop here. While low is less than equal to high, that means we have to work in the range of array only. So in this I have made the condition of if else, that if array with this mid I will be finding the array element and less than key. Fine. This is obvious because we need to compare it with the key element. Fine. We will be having the cases like it would be less than, it would be equal to, or else we'll be having the greater. Okay, so these three conditions you can form. So if your element is smaller, that is that means your key is greater than this, so we update the low as mid, because now we will proceed to the upper half of the array. If it is equal, you will give this message, or if it is less, then we will looking at in the first half of the array, and we will update the high as mid minus 1, and will keep on updating mid is equal to low plus high upon 2 for those consecutive arrays within those divisions. Okay. So this is the binary search algorithm program. So I hope students the concept is clear of linear search and binary search algorithms. So these are the algorithms that are used to perform this basic operations. These are the standard algorithms that are actually implemented in our systems, and we need to do these operations, right? So if you understand the example, the visualization of how this program is very easy to understand. We are just using the basic concept of loops and comparison, and if it is in sorting we need to do swapping, but here we need to do comparison, and linear search is simple, and if it's binary search we will keep it on updating these variables. Okay, so with this we end this lecture here. Thank you so much all.